You point your phone at a black and white square on a cafe table. It opens a menu. No password. No typing. For a second, it feels like your camera just understood paper. But that square is not a picture. It is a machine-readable sentence. A map of dark and light modules arranged so carefully that your phone can read it while your hand shakes. The lighting is bad, and part of the code is covered by a coffee stain. So what does a QR code actually do? To understand it, start with the older trick it replaced. In 1974, a pack of Wrigley's chewing gum became the first retail product scanned with a universal product code at a supermarket in Troy, Ohio. That striped barcode came from work led by people like George Laura at IBM, and it solved one problem: identifying one product quickly. A barcode is basically a one-dimensional sentence. The scanner reads left to right, turns stripes and gaps into numbers, and sends those numbers into a database. But notice the limit. A barcode mostly says, "Look me up somewhere else." It does not hold much information by itself. It does not like damage. And it has to be lined up like your scanner is reading a narrow road. Now picture a factory floor in Japan in the early 1990s. Automotive parts are arriving, leaving, being checked, sorted, assembled, rejected, and repaired. Workers need to scan parts again and again, and the old barcodes are becoming too slow. At Denso Wave, a company connected to the Toyota supply chain, engineer Masahiro Hara helped design a new kind of code in 1994. The goal was not to make restaurant menus easier. It was to make factories faster. The name QR means quick response. That was the promise. The scanner should glance and understand. The first clever move was shape. Instead of stretching information into one long row, the QR code packs it into a square grid. That turns a narrow sentence into a small page. Data can run across and down, so the code can hold far more information in the same space. But a square grid creates a new problem. How does your phone know where the code begins? How does it know which way is up? How does it avoid confusing the pattern with a checkerboard shirt, a window frame, or a shadow on the wall? That is why every standard QR code has 3 big corner markers. They look like nested squares. Your phone is not admiring the design. It is using those markers like anchors on a map. Once it finds them, it can calculate the angle, distance, tilt, and perspective distortion. If the code is sideways or slanted, your phone corrects it in software. That is the first job of a QR code. It tells the camera how to look at it. Then come the timing patterns. Rows and columns of alternating dark and light modules, like a ruler printed inside the code. They tell the scanner how big each little square is supposed to be. So before the QR code tells your phone the message, it tells your phone the geometry. Here is the corner. Here is the angle. Here is the grid. Only then does the real reading begin. Inside the square, the dark and light modules are bits. A bit is the smallest unit of digital information, like a yes or no answer. Dark might mean 1. Light might mean 0. But the code is read through rules that define size, format, mask pattern, and error correction. Size tells your phone how large the grid is. Format gives instructions for reading. Mask pattern means the code deliberately scrambles its own appearance so it does not create confusing shapes, like giant blank areas or long stripes. That sounds backwards. Why would a code hide its own message? Because cameras are imperfect. Paper is imperfect. Your hand is imperfect. A QR code is designed not just to store information, but to survive being seen badly. The survival trick comes from a deeper piece of math. In 1960, Irving Reed and Gustav Solomon introduced Reed-Solomon error correction, a method for recovering missing or damaged data. Plain English. The code stores extra mathematical clues, so even if some pieces are lost, the original message can still be rebuilt. You have probably seen this without realizing it. A QR code on a poster is scratched, a sticker is bent around a pole, or a payment code has a logo in the middle. And somehow, it still works. The QR code is carrying more than the bare message. It is carrying repair instructions. Now look again at the one on your table. To you, it is a square. To your phone, it is a checklist. Find the corner markers. Measure the grid. Read the format. Undo the mask. Extract the bits. Use error correction. Decode the message. Decide what to do next. That last step is where the QR code becomes powerful. Because the square itself usually does not contain the whole menu, the whole payment system, or the whole website. Most of the time, it contains a link. A URL is an address for a web resource. When the QR code stores a URL, it is storing a shortcut your camera can type for you. Your phone decodes the square, recognizes the text as a web address, and offers to open it in your browser. That is why the code feels magical. It collapses several actions into one gesture. No searching, no typing, no spelling mistake. Just point, read, open. But this is also the dangerous part. A QR code is easy for your phone to read and hard for your eyes to read. The same feature that makes it convenient makes it trusting. This is why security teams warn about malicious QR codes, sometimes called quishing, which means QR phishing. Phishing is a trick that tries to make you hand over passwords, payment details, or private information by pretending to be something legitimate. A fake QR code can be printed on a sticker and placed over a real one. It can lead to a cloned login page, a payment request, a fake delivery notice, or a download you did not intend to open. That is the counterintuitive twist. QR codes are not mainly powerful because they store information. They are powerful because they move decisions across a boundary. QR codes turn the physical world into a clickable surface. A restaurant table can become a website. A bus stop can become a ticket machine. A museum plaque can become an audio guide. A payment sign can become a checkout terminal. By the time smartphone cameras made scanning normal, the QR code had changed jobs. In factories, it helped machines keep track of objects. In public life, it helped objects ask your phone to do things. Apple added built-in QR scanning to the iPhone camera with iOS 11 in 2017, which mattered because the scanner stopped feeling like a separate tool. You did not have to download a special app. You just opened the camera you already trusted. Menus became touchless. Payments became contactless. Tickets became digital. Wi-Fi logins, product manuals, authentication apps, shipping labels, and advertisements all discovered the same trick. Put a square in the real world and let the phone bridge the gap. A QR code translates ink into data, position into geometry, damage into recoverable math, and a camera frame into an instruction. Most importantly, it translates a tiny physical gesture into a digital action. That is why it appears so often in places where speed matters. Not because it is beautiful, not because it is futuristic, because it reduces friction. Friction is every small effort between you and an action. Typing is friction. Searching is friction. Installing an app is friction. Remembering a web address is friction. The QR code removes enough friction that you often move before thinking. Point, tab, open, continue. That can be helpful. It can also be risky. The square does not know whether it is helping you order soup or leading you to a fake login page. It only knows how to deliver the message it was given. So the most useful way to understand a QR code is not as a symbol of convenience. It is a tiny contract. The printed world says, trust me, this pattern leads somewhere useful. Your phone says, I can read it. And you decide whether the destination deserves the tap. Next time you see one, pause for half a second. Not in fear, in awareness. Behind those little black and white modules is a factory problem from the 1990s, a barcode lineage from the supermarket age, a layer of error-correcting math from Reed and Solomon, and a modern phone camera trained to turn paper into action. You point your phone at a black and white square on a cafe table. It opens a menu. And now, you know the square did not open anything by magic. It quietly taught your phone how to read the world.